by adding our nth partial sum in to each term in that remainder inequality, we get that the actual sum of this series, which is equal to the nth partial sum plus the sum of all remaining terms so that this is the true value of this series, is going to be less than the partial sum plus this integral from n to infinity of f of x dx, and it's going to be more than the nth partial sum plus the integral from n plus 1 to infinity of f of x dx. Notice here, so I had sort of carelessly written in that these are less than or equal to, that all of these inequalities are less than or equal to, and it's not incorrect, but they are strict inequalities here. So let's correct that now. Let's write this as strict, since we know that we have that these functions are increasing. Okay. Now, so this gives us an interval in which we can look for the sum of our series. So we know that the sum of our series lives in the interval Sn plus the integral of n plus 1 to infinity f of x dx. Sn plus the integral from n to infinity of f of x dx. Since this integral is often going to be quite small, we're often satisfied to just compute, to just use the upper bound, or excuse me, the lower bound of Sn as an estimator for the sum of the series. But if you don't mind computing an extra integral, this one, we can slightly tighten the interval in which we will find the sum of our series.